Hello everyone, this is Bsc FY class, that is Differential Calculus. So in last some lectures we have discussed some examples which helps us to difference between the differentiability and continuity of a function. We know that if the function is a differentiable at some point, then it is a continuous at that point. But if the function is continuous at some point, then we cannot say that the function is a differentiable at that point. So the function may be continuous at some point, but may not be differentiable at point. For example, fx is equal to mod x, which is a continuous at x equal to 0, but not differentiable at x equal to 0. There are so many examples which are continuous at some point but not differentiable at that point. So today I am going to discuss the geometric interpretation of the derivative. Geometric interpretation of the derivative. Geometric interpretation of the derivative We discussed the definition of derivative of a function at point C. So what was the definition of derivative of a function at point C is denoted as f dash at C is equal to limit h tending to 0 f of c plus h minus f of c divided by h. If this limit exists, then we say that the function is differentiable at point C, and the value of the limit is called the value of the derivative of a function at point C. So before going to start the geometric interpretation of the derivative, you must know two things. So what is meant by tangent and what is meant by equation of the tangent. So if we consider a function y is equal to f of x, so this is our Cartesian coordinates. This is y-axis, this is x-axis. This is our Cartesian plane. If this is a curve, y is equal to f of x. So this is a given curve, y is equal to f of x. That is, this is a function whose domain is the set of real numbers. That is this real line. And if we draw a line, which touch to the given curve at only one point, then we say that this line is tangent to the curve y is equal to f of x. So this is a tangent. So tangent touches the given curve at only one point. It touches given curve in only one point. So this is called as a tangent to a given curve. So definition of the tangent is it is a line which touches the given curve at only one point. Now, if you have a given 2 points on the line, x1, y1, this is x2, y2, then we can calculate the equation of this line, and which is y minus y1 divided by y1 minus y2 is equal to x minus x1 divided by x1 minus x2. If we have given any 2 points on the line, then we can calculate the equation of the line. So this is the basic behind the geometric interpretation of the derivative. So in geometric interpretation of the derivative of a function at point C is nothing but the slope of the tangent drawn to a given curve at point C. So derivative of a function f dash is equal to C is slope of the tangent at point C. Slope of the tangent at point C. Now consider this is our y-axis and this is x-axis, and the given curve is like this. Now draw any tangent at point C. If this is the point C, and this is f of C. Now if you draw a tangent which touches the given curve at point C, then slope f dash at C is nothing but the slope of this tangent at point C. Now also, if this is a Cartesian x and y, and this is a given curve, this point is a C, this point is C, and this point is C plus h. Now the value of a function f at C is fc, and the value of the function f at C plus h is f of C plus h. Now if we draw this line, so this point is Q, this point is P, and this point is R. Now the slope of the curve at point C is tan theta is equal to y2 minus y1 divided by x2 minus x1. y2 is y coordinate, that is this is y2, this is y, and x2 minus x1 is x coordinate, that this is x1, this is x2. So from this we can calculate f of C plus h minus f of C divided by C plus h minus C. So this is the slope of the tangent tan theta. If we take a limit on both sides, then limit h tending to 0 tan theta is equal to, if we put limit from a right side, then this is f dash at C. So f dash of C is nothing but the slope of the tangent at point C. Now write down the theory behind the geometric interpretation of the derivative. To show that f dash of C is the tangent, f dash at C is the tangent of the angle, is the tangent of the angle means tan theta. Tangent of the angle means tan theta, which is tangent line to the curve, which is tangent line to the curve, y is equal to f of x, which is tangent line to the curve, y is equal to f of x at point C comma FC. This is the point on the curve. Makes with x-axis. Makes with x-axis. Makes with x-axis. Now proof for working rule. So given curve y is equal to f of x. Consider 2 points. Consider 2 points on the curve. First point P, C comma FC. C comma FC, and second point Q, C plus H comma f of C plus H. These are the 2 points on the given curve. Now consider the curve in Cartesian plane. So if this curve and this is the tangent drawn to the curve at C, this is P, and if we draw a line to the curve from point Q, so this is Q, this is P. If we draw a tangent on the x-axis, so this point is C and this point is C plus H. So this is x-axis, and draw PR perpendicular on Q. Now if we replace A comma B, this point is C, this point is C plus H. Draw perpendicular PR on QB. PR on QB. Then now note that this is M. Now note that angle BMQ, it is equal to angle RPQ. It is equal to angle RPQ. So which is QR divided by PR. QR divided by PR. QR divided by PR. But what is QR? QR is what? QR is f of C plus H minus f of C. And what is PR? PR is what? C plus H minus C. So C cancel, it is H. F of C plus H minus f of C divided by H, which is QR divided by PR. QR divided by PR. Now taking limits on both sides, then limit h tending to 0 QR divided by PR, which is equal to limit h tending to 0 f of C plus H minus f of C divided by H. So what is this QR divided by PR? So this is perpendicular. So QR divided by PR is tan theta, which is tan theta, and this is what derivative of a function at point C. Therefore, from this we can directly say that the derivative of a function at point C is nothing but tan theta. That is slope of the line, slope of the tangent drawn through the curve at point C with respect to x-axis. Now one curve. The equation of the tangent at the point corollary. The equation of the tangent. Tangent is a line, so we must have a equation. The equation of the tangent drawn. The equation of the tangent drawn at point P. At point P, the point is C, FC to the curve y is equal to f of x is to the curve y is equal to f of x is y minus f of c is equal to f dash at c into x minus c. F dash of c into x minus c. Now proof of this corollary. Now if the given curve is this, now we are given and let the tangent to the curve is if this is a given curve y is equal to f of x and the tangent to the curve is this. Now we have to calculate the equation of this tangent. Now we have 2 points on the tangent, P and this is Q. So Q is what? C plus H comma f of C plus H, and P is what? C comma f of C. Now if we have 2 points on the line, then we can calculate the equation of this line. So if this is x2, y2 and this is x1, y1, then the equation of the line is y minus y1 divided by y1 minus y2 is equal to x minus x1 divided by x1 minus x2. So this implies that y minus y1. y1 is what? y1 is f of c divided by x1 minus x2. So c minus c plus h. x1 minus x2. c minus c plus h. So which is minus h. So and equal to x minus x1 upon x1 minus x2. x1 is what? x1 is y minus y1 upon y1 is f of c. y1 minus y2. y1 is f of c, sorry. f of c, y2 is f of c plus h. f of c plus h, and x minus x1, x1 is c, and x1 minus x2, c minus c plus h, so which is minus h. Now from this we can write y minus f of c divided by x minus c is equal to f of c plus h minus f of c divided by h. Now taking limits on both sides, we have limit h tending to 0, y minus f of c divided by x minus c is equal to limit h tending to 0, f of c plus h minus f of c divided by h. So this is nothing but f dash of c, f dash of c, and this is as it is, y minus f of c divided by x minus c. Now rearrange this. So from this step we can write y minus f of c is equal to f dash at c into x minus c. So this is the required equation of the tangent. So this is equation of tangent. सो आजच्या लेक्चरसाठी इथंच थांबूया. उद्या आपण काही थेरम्स आणि एक्झाम्पल डिस्कस करूया. थँक्यू.